Here's a geometry question. It's got two circles, circle P and circle Q, that have a shared chord, a common chord, AB, which is perpendicular to the segment connecting the centers of the circle. So I'll draw the circle on the right in red, and the circle on the left is already blue. I'll keep it in a nice blue, bluish blue. Okay, so there's the common PQ connects the centers, and there's the chord that's common to both of them. Well, let's see. It says AB is 10. AB is 10. If there is a chord of a circle that is cut by a segment that is a radius or a diameter, it's perpendicular, that turns it into two equal portions. It bisects it. So if AB is 10, each one of these parts are 5. And so now, I don't know what to call this point, but from the center point to Q, I can use this triangle. That's a 5. Hypotenuse is 9, and I'll call that X. Before I do this, let me try to estimate it. Is this thing drawn to scale? This is 11, this is 9. 9 is shorter than 11, and they look shorter. I think this is maybe drawn to scale. So if I look at this, that looks like it's about 11. It looks like PQ is certainly bigger than 11. Let me look at the answer choices. I just want to do this first. 9.8 smaller than 11, can't be. 5 smaller than 11. 6.3 smaller than 11. Those are not negatives, those are approximately. 7.4 smaller than 11. It's got to be that one. AB looks like PQ is bigger than 11. It's bigger than 10, it's bigger than AB, and it's bigger than 11. But anyway, so because this segment that's a radius is perpendicular to that chord, it cuts into two pieces, I've got 5. So I've got a 5, 9 something, and then the other triangle, I want to find P to that center point, that's 11, 5 and something. So that one looks like this, 11, 5 and something. I'll call it Y. How do I find that? Well, Pythagorean Theorem, x squared plus 5 squared, which is 25, equals 9 squared, which is 81. X squared equals 81 minus 25, 71, 61, 56. X squared is 56. X is then the square root of 56. So I'm calling, let's see, that's the 5, 9x. I'm calling this part, I'll put this in, well, I don't know what's going to show up now. I'll put this in yellow. That part I'm calling X, and then I know I'll do this part in green. That green part is going to be Y. All right, how do I find Y? 5y squared, leg squared, plus leg squared, 5 squared is 25, equals hypotenuse squared, 121. Y squared equals 121 minus 25 is 100, minus 4 more is 96. Y equals the square root of 96. And that segment then is x plus y. PQ is x plus y. Square root of 56 plus square root of 96. You can throw it onto a calculator. 7 is 49. 8 squared is 64. This is somewhere like 7.5 maybe. And this is 96. It's almost 10 plus 9.8. These are estimates. 8 and 5 is 13. 9, 7, 16, 17. Somewhere around 17.3. I just made estimates, but you can plug it into a calculator. Square root of 56 plus square root of, was it 96? 17.28, 17.3, and verifies the answer that I got by estimating and getting. So you can't, unless something tells you that these figures are drawn to scale, like on the ACT tests, figures are drawn to scale unless it says it's not drawn to scale or unless they're 3D. On an SAT test, figures are drawn to scale unless it says not drawn to scale. On this, it doesn't say, but again, I could see that 11's bigger than 9, and they look like PA looks bigger than AQ, so now I'm thinking it's drawn to scale, and that's how I was able to estimate it. But anyway, so just make triangles and figure out, using Pythagorean Theorem, what those side lengths are. I got square root of 56 for one and square root of 96 for the other. Square root of 56 plus square root of 96 is 17.28, whatever it is. There's the answer to this question.